Welcome to ECE 463, lecture number 1, Matlab review. Now in this course, we use Matlab extensively. This is just a quick review of Matlab. Most of the stuff that you'll need we'll be covering in this course. But just to give you a little bit of background on what Matlab is, I'd like to cover the console, the editor, the graphics window, the help menu, and saving your data. Now to start out, in Matlab you get the console window that has the list of all the different M files in your current directory, the command window, the workspace, and command history. Now typically all I care about is the command window, so I'll close all the other ones down just because they get in the way. For using Matlab, Matlab is very similar to a calculator, except it's a calculator that does complex numbers, which is what we need for this class. In the command window, you can type in operations like x equals 17 over 3, and you get 5.66. You can do commands like parentheses 3 plus 4, quantity times 5, 35. It's got numbers like pi, I, j, e. If you want the result to display in Matlab, you don't put in a semicolon. If you don't want it to display, I do. For example, if I say x equals 2 times pi, it'll do the operation but not display the results, but it does calculate what x is. If I take out the semicolon, it displays what x is as well as does computation. That's actually kind of useful. What I like using Matlab for is a calculator. Take out the semicolon so you can see your work as you go along. That's especially important in this class where you have a bunch of matrices. You need to make sure that the dimensions are correct. For example, if you want to add a 1 by 3 matrix plus a 1 by 3, that works. If I have a 1 by 3 plus a 3 by 1, that doesn't work. You can also change how many decimal points are displayed. Format short is the default, gives you 4 decimal points. Format long gives you a whole bunch. Long E is exponential notation with a lot of decimal points. Short engineering is engineering notation with 4 decimal points, and so on. As I mentioned, Matlab is a matrix language. To start a matrix, you do a square bracket. To end the matrix, you do a square bracket. Comma or space means next element. Semicolon means next row. So if I say A equals 1, 2, 3, that's a 1 by 3 matrix. 1, 2, 3, semicolon, 4, 5, 6 gives a 2 by 3 matrix. And a single quote is a transpose. In Matlab, you can do for loops. This is the syntax for for loop. If I say for I equals 1 to 3, it's going to count. I is 1, then 2, then 3, then exit. If I do that, I wind up with x being a 1 by 3 matrix with an element of 1 squared, 2 squared, 3 squared. I can do while loops. This is actually we do quite a bit in this class. If I want to do a simulation, I'll say as long as time is less than 10, or while t is less than 10, do the following, and I can run a simulation. What while loops do is they run as long as the condition is true, it keeps on looping. As soon as it's false, it kicks out. You can do if statements. I kind of like saying that you can do anything with an if statement. With Matlab, there's if else, and else if. So you can say for I equals 1 to 4, it's going to count I equals 1, 2, 3, 4. If I is 3, the next is 10. Otherwise, x is 2y plus 3. And if you look at it, the third element is 10. The other ones are just 2y plus 3. That's an if statement. For this class, there's a couple commands we'll be using that are related to control systems. Poly is create a polynomial whose roots are at -1, 2, 3, and 4. What this means is this is decreasing powers of s. This means s to the 4th plus 10s cubed plus 35s squared plus 50s plus 24. Again, Matlab is a matrix language. It's actually written in C. It's really easy to input a matrix in C. It's really hard to input polynomials. So the notation Matlab uses is it just uses the coefficients in a matrix. And what that means is decreasing powers of s. The converse of poly is roots. If I have a polynomial that's x to the 4th plus 10x cubed plus 35x squared plus 50x plus 24, find the roots, and it's right where we put them, -1, 2, 3, and 4. To input a system into Matlab, there's a couple commands. There's ZPK, TF, and SS. State space we'll be covering a little bit later. That's the main thing we do in this class. But there's other ways. I can input the transfer function as the numerator polynomial, 0 at -1, denominator polynomial, roots at -2, -3, -4, and again on top of 5. Or I can just input the transfer function as 5, 5, 1, 9, 26, 24, which means, in decreasing powers of s, 5s plus 5, s cubed plus 9s squared, and so on. Once you have the system into Matlab, I can then convert. Once I input the system using ZPK, I can find the transfer function. Given the transfer function, find the zeros and poles, or state space. For state space is a way to represent a system in matrix form. Again, Matlab loves matrices, so this is actually how Matlab stores systems. In matrix form, I have 2 or 4 matrices, A, B, C, D. That's your x dot equals ax plus bu, y equals cx plus du, something we'll be covering quite a bit this semester. To input the system in state space form, I first have to define what is A, B, C, D, input the system as state space. Once I have that, I can then say, okay, given the system G, what is it in zeros and poles form? What is it in transfer function form? That's pretty useful in this class. The state space actually is fairly easy to input. Once you have it in state space, I sometimes want to see what's the transfer function. This tells me more about the system. For example, here's my dominant pole at -0.22. That tells me the settling time, tells me the overshoot, tells me quite a bit about the system. To find the gain of g of s at some point, that's EVALFR. This is g of s evaluated at s equals j3. It will also do the step response. So if I input my system and my time points, I can say what is the step response of g, and then plot. One command we don't use that often, but it is available. There's also the impulse response. Instead of the input being the unit step, it's the unit impulse, a delta function, and this will find the impulse response. Again, not quite as useful for this class, but it's there. Eigenvalues. In state space form, we have matrices A, B, C, and D. The eigenvalues of A are all important. The eigenvalues are the roots. If you have the system and find the transfer function, that's what these will be. And if you kind of notice, the same system we've been looking at. Here's the transfer function. I've got poles at -0.2, -1.1, -2.4, 3.6. Those are the eigenvalues. The characteristic polynomial is the denominator polynomial. That's the polynomial with roots at the eigenvalues. And Matlab will also do eigenvectors. Very few people understand eigenvectors, but they are useful. Eigenvalues tell you how the system behaves. Eigenvector tells you what behaves that way. For this system, I've got 4 eigenvalues, a fast mode and a slow mode. This is the slow eigenvector. If that's my initial condition, it decays as e to the -0.22t. If this is my initial condition, that decays as e to the -3.6t. Determinant, not used that much in this class, but it's available. The determinant is the product of the eigenvalues. Basically, if the determinant is not 0, the matrix is invertible. It's also the product. It's the product of the eigenvalues. The trace is the sum along the diagonal. That's the sum of the eigenvalues. Again, not terribly useful, but kind of interesting that the eigenvalues keep coming into play. All that you can do with the command window. Scripts are also useful. If you want to run the same function over and over again, and you don't feel like typing it in over and over again, I can throw it in a script. This is just a set of commands I'm going to execute in the command window, but rather than copy-paste, I can hit this arrow right here, and then it executes the script. That's kind of nice because I can sit there, run a simulation, change some gains, try it again, change some gains, try it again. That's very useful in the homework sets where you're trying to find gains to stabilize the system, like a ball and beam system, cart and pendulum system. As an example of scripts, this is a listed view figure. So this is more fun if you actually see it. Matlab actually does really good animation. Here I've got the script. When I hit the arrow, it starts executing it, which you see over here on the right. What's happening is this is my angle, goes from 0 to 2 pi with 100 steps. There's my time vector, my step size, and for 10 seconds I'm going to run the following. That's a while loop. If x is cosine, y is sine of 2t plus a phase shift. Plot, x-lim sets the x-axis between -1 and +1. Y-lim sets the limits on the y-axis between -1 and +1. Pause, pauses the display so I can see it, and then increment time. This will run for 10 seconds, and what you see is a Lissajous figure. Kind of looks like a crown that's rotating. That's an advantage of the script. If I change it, let's go into Matlab right here, hit Control-C to break out. I could then have this run faster and make it sine of 3t, 4t. This is the advantage of scripts. I can make a small change, run it, and then see what it looks like. So I don't have to type this all in over and over again. That's the script. And again, if you're running a script and you want to get out, Control-C gets you out, Control-C kicks out. That's an old WordStar command from 1980. And Matlab can also create functions. For example, suppose I want to roll n dice of size m. I could write a function. Rather than having to write that routine over and over again, I can come up with a Matlab function called dice. I'm going to tell it I want to roll 10 dice, or 20 dice that are 6-sided, and it'll calculate the result, sum them all up, and say that I just sold 83. The nice thing about functions in Matlab, once I create this, this is a function that anybody can use in Matlab now, as long as they have my current directory, have that M file. Also, when you type in a command like dice, what Matlab does is says, do you have a variable called dice? If you do, it tells you that value. If there aren't any variables called dice, it'll say, is there an M file? Is there a function with that name? If there is, it'll call that function. If that doesn't exist, then it'll tell you error, I have no idea what you mean by dice. This is actually really powerful. This is one of the reasons Matlab really took off. It's very easy to create your own custom functions. So what companies have done over the years is they've written their own functions to help design better jet engines, better fuel controllers, and so on. Those functions are the company proprietary knowledge that lets the companies build better devices than their competitors. What really makes Matlab powerful is the ease of creating your own functions. Another example. If I want to compute the acceleration of a ball rolling in a bin, I can sit there and calculate. I'm going to pass the position of the ball, or pass x, it's the vector. X means I've got position and velocity. I will then iterate and say, given the position velocity, here's acceleration versus time. Some of the other functions in Matlab, again, there's thousands and thousands of functions. These are some of the more common ones. Got polynomials, trig functions, probability and statistics, display functions, generally useful commands, various utilities. The main ones we use in this class are for system analysis. Again, you got transfer function to input a system, CPK, another way to input the system. The big one for modern control. Input a system in state space form. Find the eigenvalues of G or eigenvalues of A, same thing. What are the poles of the system? Give me a polynomial that has these roots. Given these roots, what are the find the roots of that polynomial. Find the polynomial with those roots. Evaluate G of S at a point. Find the step response, and something we'll use later on in the semester, find the feedback gains to stabilize it. So that's kind of a summary of Matlab. Again, we'll be using it extensively this semester. I would highly recommend getting Matlab installed on your computer. If you would like to do that, there's a link on Bison Academy for how to download Matlab and get a site license free for all NDSU students while you're at NDSU. So that's lecture number 1 for ECE 463, Modern Control.